In this mini lesson or mini video, we're going to look at some examples for compositions of functions. Now, a composition is one function in terms of the other. And so what essentially you're doing is you are plugging one function into the variable of another function and then simplifying and evaluating. So here in this first example, we're given two functions, f of x and g of x, and we are going to look at the composition. Okay, so f, this little open 0 means composition of. So f of g of x, and then we're going to do g of f at -2. So the first thing we need to do is do f of g. So the way I like to do it is I like to look at which is going to be my outermost function. So that's the function written first, so this is my x. Anywhere that I have x's, I replace them with a placeholder. So this is going to become 2 of something squared minus 3 of something. And this is how I help myself to remember that my x's here are going to be replaced with a different function. And in this case, what they're being replaced with is your g function. So that's what goes in there. My g is x plus 7. So what this actually becomes is 2 times x plus 7 squared minus 3 times x plus 7. Once you have figured out which function is on the outside and which function you have to plug into, now all you have to do is expand it and simplify. So here you're going to use your FOIL method, and then over here you are going to distribute. So in doing all of that, when you FOIL, you're going to have 2 on the outside, and then this is going to become x squared plus 14x plus 49. And then this is going to be minus 3x minus 21. You're going to distribute your 2 through, so this is going to become x squared plus a 28x plus 98 minus a 3x minus 21. So your end result is going to be your 2x squared plus 25x plus 77. And this was f of g. So here is your first result. Now the reason I know I'm done is because I am evaluating by x, which means my x here's turn into x's, and so they stay the same. Now the other one wanted us to look at g of f. G of f says I'm going to start with g, so I have my placeholder plus 7. And remember, what's going in your placeholder here is going to be your f. So this is going to end up being 2x squared minus a 3x plus 7. Now in this case, there's nothing else to do to simplify, so now we have to do the evaluation. And in this problem, we are evaluating by -2. So here, when we do g of f evaluated at -2, what that means is anywhere you have an x becomes a -2. So when we finish that out, our g of f at -2 is going to end up being 21. And there is your second result, composition. Now the other thing that we can do with compositions is not only can we solve a composition, but we can also find the domain of that composition. So there's a couple of guidelines that you need to follow. First, in order to find the domains, you would first find the domain of f and g separately. Then you're going to complete your composition. And the third thing is you're going to find your domain of the composition using one of these two methods. The first is going to apply most of the time, which says that you're going to look at whatever your result of your composition is, and then you're going to figure out which values have to be included and exclude the values that make it undefined. If you have radicals, you're going to look at your composition and then use your radical rules if you have a radical. So in other words, your domain would have to be greater than or equal to whatever the value is that makes it 0. So when doing domains of compositions, I just find it best to look at an example. So here we've got f is my outermost function, so this becomes 1 minus a placeholder. And remember, what's going in here is my g function. So my f of g is going to be 1 minus the square root of x. So the first thing I look at is my domain of f. Well, f is linear, so my domain here is going to be all real numbers, which is negative infinity to positive infinity. My domain of g is going to be that x is greater than or equal to 0. So now when I'm looking at the domain of my composition, I'm looking not just at the overlap, but at what the actual composition is telling me. And in this case, my domain for f of g is going to be that x must be greater than or equal to 0. In other words, we have from 0 to positive infinity is what makes it true. Now, in the other, when we look at g of f, well, g is the square root of x, so this is going to become the square root of f. So this is really going to be the square root of 1 minus x. Again, if I look at my domain of f, it is all real numbers, negative infinity to positive infinity. My domain of g was still going to be the same, x is greater than or equal to 0. But now when I look at the domain for g of f, I have to take into account the fact that I have something new underneath my radical. So my domain here is going to become that 1 minus x must be greater than or equal to 0. So I need to figure out what the value is. I'm going to subtract the 1 and divide by the negative, so I end up with x must be less than or equal to 1. So here, when you're writing it out, what this tells you is you're going to go from negative infinity to 1. So notice, I took the domains of my individuals, but I didn't look at necessarily the overlap. I actually looked at what the composition was. Let's look at one more. So here I'm again going to start out with doing f of g. So this is going to end up being 4 placeholder minus 2 divided by 3, and remember what goes in here is my g function. So in this case what I end up having is 4 times 1 over x minus 2 all over 3. And so we can actually do a little bit of work in order to make this look a little nicer. So here the first thing that we would do is we would distribute. This becomes 4 over x minus 2 all over 3. I need to be able to combine my upper fraction here. So this is going to give me 4 minus 2x all over x all over 3. Use your fraction rules, which say keep the top and use the reciprocal of the bottom. So this is going to give me 4 minus 2x all over 3x. So this is my actual f of g right here. Now with that, I need to be able to find its domain. So the first thing is I want to look at your domain for my f. So if I look here at f, notice I'm not going to have any problems. So this is going to be negative infinity to positive infinity. If I look at my domain of g, notice here I have an issue at 0. So in this case, x cannot be 0. So now I need to look down here at my f of g. So the domain for my f of g is going to be such that I cannot have a 0 in the bottom. So what I know is I know that my 3x cannot be 0, so x cannot be 0. What that also means then is that my domain here is going to go from negative infinity to 0, union 0 to positive infinity. And this is the domain that we were looking for. Now the other piece that we can do is we can look at g of f. So in this case, when we look at g, this is going to be 1 over, and this is going to be my f down in the bottom. So here this becomes 1 over 4x minus 2 divided by 3. So in this case, I'm going to use my fraction rules, which say keep the top and flip the reciprocal of the bottom. So this becomes 1 times 3 over my 4x minus 2. So in this case, we actually have 3 over 4x minus 2. Again, we can look at the domains, but this right here is going to be g of f. So in this case, my domain of f was still going to be the same. It's still going to be all real numbers. My domain of g is still going to be that x cannot be 0. But in this case, my domain for g of f is going to change. And it changes because of what's happening here in the bottom, in the fact that this now is going to say that 4x minus 2 cannot be 0. Solve for x and we end up with that x cannot be 1/2, which means my domain here goes from negative infinity to 1/2, union 1/2 to positive infinity. And this would then be my compositional domain. Alright, So that is kind of everything you need to know for a mini review on compositions and finding their domains. If you have any questions, please let me know. Otherwise, I will see you next time.